We think of stars as these great creators in the cosmos. They're these nuclear furnaces, forging the very elements that make life, our planet, everything possible. But here's the thing. That same incredible power has the dark side, a really violent, destructive potential that, if the circumstances are just right, could wipe us out in the blink of an eye. So how could these creators become our executioners? Let's take a look at the cosmic killers hiding in plain sight. And that quote, that really gets to the heart of it, doesn't it? We are talking about forces on a scale that is just almost impossible to wrap your head around. Events that could happen light years away, but still totally determine our fate right here on Earth. It's a pretty terrifying question, but it's also a fascinating one. What exactly are these stellar time bombs? And how, specifically, could they end everything we know? Well, that's what we're about to break down. So here's the game plan. We'll kick things off by just trying to frame the immense power of the universe. Then we'll get into two big-time threats from distant stars, the supernova and the gamma-ray burst. After that, we're going to bring the danger a lot closer to home, before we wrap it all up and ask what this all means for our little blue marble. It's so easy to look up at the stars and just see this peaceful, static, quiet void. But the truth is, the universe is a place of constant, unbelievably violent creation and destruction, and we just happen to be living in the middle of it all. All right, let's dive into our first major threat category, the supernova. The easiest way to think about this one is like the universe's shotgun blast. It's a massive, indiscriminate explosion from a dying star that just sprays destruction everywhere. So what is a supernova? Well, in its last moments, a really massive star collapses under its own weight, and then it rebounds in the most violent explosion you can possibly imagine. This blast launches this wave of lethal radiation and high-energy particles out in every direction, a cosmic shockwave that can just keep traveling across the galaxy for thousands and thousands of years. And what's kind of wild is just how many of these supernova candidates are right in our cosmic backyard. I mean, we've got the famous red supergiants like Betelgeuse and Antares, the super bright blue supergiant Rigel, a binary system called Spica, and the one that's closest of all, IK Pegasi, just 150 light-years away. That's practically next door in cosmic terms. Now, Betelgeuse gets all the attention, and for good reason. At about 600 light-years away, it's close enough that when it finally does blow, that wave of high-energy particles, that ionizing radiation, could be strong enough to actually damage our protective ozone layer, leaving us totally exposed to the sun's worst radiation. And this perfectly highlights our main line of defense: distance. Just pure, empty space. Even though IK Pegasi is way closer than Betelgeuse, scientists figure it would have to be even nearer for its explosion to cause a true, planet-sterilizing extinction-level event. So, for now, the sheer vastness of space is our best shield. But what happens when the universe trades in its shotgun for a sniper rifle? Okay, so if a supernova is a shotgun blast, then a gamma-ray burst, or a GRB, is the universe's sniper rifle. And frankly, it is a much more focused and much more terrifying kind of threat. We're talking about the single most powerful explosions the universe can create, period. Unlike a regular supernova that blasts energy in all directions, a dying hypergiant, a star way bigger than your typical supernova candidate, can focus almost all of its explosive power into two incredibly narrow, powerful beams that shoot out from its poles, like a cosmic death ray. So let's meet our first suspect, WR104. It's a special kind of super-hot, unstable star called a Wolf-Rayet, basically the perfect ticking time bomb for a GRB. Now, it's over 5,000 light-years away, which, that sounds pretty safe, right? Well, with a GRB, distance is only half the story. The other, much more important half is the aim. If that beam isn't pointed at you, you're fine. But if you happen to be right in the line of fire, it doesn't really matter how far away it is. And for a while there, it looked like WR104 might be aimed right down our throats. And the consequences? They'd be absolutely apocalyptic. I mean, a direct hit would shred a huge chunk of our ozone layer in just seconds. The flood of radiation hitting the surface would ignite firestorms all over the planet, leading to a mass extinction event within hours. It would be an almost instantaneous end. And if WR104 wasn't scary enough for you, let me introduce you to Eta Carinae. This isn't just a big star, it's a true monster. a hypergiant that weighs in at over 100 times the mass of our own sun. It's almost hard to even picture that. And a star this massive doesn't just go supernova. No, it goes hypernova, a completely different class of explosion, powerful enough to create one of those terrifying, focused gamma ray bursts. Now, thankfully, the latest info suggests its axis is not pointed at us, but just the fact that it exists is a pretty chilling reminder of the incredible forces at play out there. So we've been looking thousands of light years across the galaxy for things that could kill us. But what if the biggest danger isn't out there in the deep dark, but right here in our own backyard? Because when you really factor in things like probability and just how close it is, the star most likely to cause absolute devastation on Earth is our own sun. Now, it's not going to explode in a supernova, not for billions of years, but it doesn't have to explode to cause a complete catastrophe. You see, our star's main weapon is something called a superflare. It's a gigantic burst of magnetic energy, way more powerful than a normal solar flare. If a really big one hit us today, it could instantly fry our satellites, collapse power grids across the entire world, and basically throw modern civilization back into the Dark Ages. And in a really extreme, once-in-a-millennium event, a superflare could even be strong enough to damage our atmosphere and trigger a mass extinction. So, from supernova shockwaves to cosmic death rays and even the fury of our own star, it is crystal clear that we live in an incredibly powerful and, yes, sometimes hostile universe. So, what do we take away from all this? Well, first, that the cosmos is just an unbelievably dynamic and violent place. Second, that our best protection is simply the unimaginable amount of empty space between us and these cosmic bombs. And finally, that the calm, stable existence we have here on Earth, man, that is a truly precious and maybe a very rare thing. It all leaves you with this one last kind of humbling question. In a galaxy that's filled with stellar killers and cosmic crossfire, is the fact that we're all still here a testament to our planet's resilience? Or is it just a streak of incredible cosmic luck that could run out at any second?